everyone, my name is Sophia, and in this video we're going to be going over periodic trends, which you're going to find on your Module 12. So let's get started. So the first periodic trend found in your periodic table, I guess, is atomic radius. So basically, guys, for atomic radius, this depends on the interaction between protons in the nucleus and electrons in the different energy levels around the nucleus. Remember how the different energy levels are at different distances from the nucleus. Therefore, if you have a higher energy level, that's going to be further apart from the nucleus, making it less attracted to the positive part of the nucleus, rather than, say, the first energy level that is going to be more attracted to the positive charge because it is closer to the nucleus. So that being said, guys, let's look at our period 1, lithium and sodium. So lithium, guys, we know that it has two energy levels, right? And sodium, we know it has 3 energy levels, right? So 1, 2, and 3. So if I ask you, which one has a greater atomic radius, which one would you think it would be? Well, your answer should be the sodium, because since the sodium has an electron occupying a space in this third energy level, guys, this electron is going to be less attracted to the positive side, positive inside of the sodium nucleus. Rather, say the lithium electron found on the second energy level, that's going to be more attracted towards the nucleus of the lithium, right? Because it's more close. It's more proximate to the nucleus. Therefore, the sodium is going to be a little more expanded and have a greater atomic radius. So what we can see, guys, is that as you go down the periodic table, your atomic radius increases. Okay, so now, what if we're talking about elements in the same period but not the group? So let's say lithium and beryllium. So lithium and beryllium both have 2 energy levels, right? However, what is the difference between these two guys in the nucleus? The difference is that lithium has 3 protons in the inside. Recall that the atomic number of an element equals to the number of electrons, and the number of electrons equals to the number of protons. So lithium has 3 protons in the nucleus, and beryllium has 4 protons in the nucleus. And recall from the beginning that we said that the atomic radius depends between the interaction of these protons in the nucleus and the electrons surrounding it. So what will happen in this case, guys, is that since beryllium has a more positive nucleus, more electrons, more electrons are going to be pulled with a greater force towards the nucleus, right? Because it is more positive, say, than lithium. Therefore, beryllium is going to be smaller, right? It's going to be more compact because it's more the positive charge is pulling the electrons, so they're not going to be all dispersed. Therefore, lithium would have a greater atomic radius than the beryllium. So we can conclude that in this case, the atomic radius increases from right to left. Okay, so now that we've learned that, let's do this problem. So it says, organize the following elements in terms of increasing atomic radius. Okay, guys, so if we look at these, let's locate all of these first. So we have silicon here, chlorine here, potassium, calcium, and rubidium, right? Okay, so we know that the elements increase in atomic radius as you go right to left and as you go down. Okay, so which one would have the smallest in this case? Your answer, guys, should be chlorine, followed by silicon. So chlorine is smaller than silicon. Silicon is smaller than calcium. Calcium is smaller than potassium, and then finally, potassium is smaller than rubidium. So in this case, our largest atomic radius would be rubidium, right? And if you think about it, it makes sense because rubidium would have 5 energy levels. So yeah, let's go to the next problem. So now this problem is saying organize the following ions in terms of increasing atomic radius, guys. Okay, so the thing with ions, guys, is that they don't follow the same trend as we were following in the previous problem, because the previous problem is talking about elements at ground state, right? But this is ions, they have charges. So the rule for this, guys, is that the more positive an ion is, the smaller it is. Okay? And the more negative, the bigger it is. Okay, so here, out of all of these guys, which one has our biggest atomic radius? Well, the more positive, which is calcium 2+. So our calcium 2+ should have the smallest atomic radius. I apologize, I think I said greatest. The smallest, because it has a more positive charge, smallest. So calcium 2+, followed by potassium plus, followed by a negative one, but not that negative, not the most negative, chlorine, followed by sulfur 2-, followed by phosphorus 3-, which has the greatest negativity. So yeah, so this is how you organize ions, guys. Always based off of positives. The more positive, the smaller. The more negative, the bigger. When we are talking about atomic radiuses. So yeah, so now let's go on to the next slide. Okay, so basically, guys, for this one, ionization energy, electron affinity, and electronegativity are other periodic trends. And for these guys, what happens is that all of these follow the same direction, I guess. I'm going to tell you a little bit about each. So ionization energy is the energy that is needed to remove an electron from an atom. This depends on the energy of the outermost electron. If we were to think of atoms in terms of their radius, this concept makes sense, as the further apart they are from the nucleus, the easier it is to remove an electron, and the closer the electrons are to the nucleus, more energy is required to remove an electron. So yeah, that makes sense, right? So think about it. I like to think about it as like when I go down Black Friday, guys, and like you just go like for one item, like it's so much harder for someone to steal that item from you than say if you have like your little cart with you, right? So like the further apart you have your items from you, the easier it is for those items to get stolen, right? So the same thing with electrons. The further apart they are like in the outermost like energy levels, the easier it is to steal those electrons. So yeah. So that's for ionization energy. And then electron affinity, guys, is the negative change in the energy that it takes for a specific atom to accept an electron. So basically, this is the energy released when an electron attaches to an atom to form an anion. And so yeah. And finally, guys, electronegativity. And electronegativity is the measure of how strong a certain atom attracts a shared pair of electrons towards itself. We know, guys, by the way, that fluorine, I'm going to write like a big F, fluorine, it's this one up here, is the most electronegative element. So this is a great rule of thumb to like figure the electronegativities of elements. So yeah, so you just compare like their distance from fluorine, and that's how you should go. So if I give you, for example, boron, carbon, oxygen, and nitrogen, you'd say, and then like out of these, which is the most electronegative? Your answer should be oxygen, because it's the closest one to fluorine. So yeah. So that's for those three periodic trends. So let's do this problem. So it says, organize the following elements in terms of increasing first ionization energy. So for this one, guys, as we saw on the previous slide, the rule for this is that ionization increases as you go up the periodic table and increases as you go across left to right on the periodic table. So let's find all of these. So we have calcium, aluminum, chlorine, sulfur, phosphorus, fluorine, and francium, right? Okay, so which is gonna have have the least ionization energy? So it should be francium, right? Because it's the one furthest apart, right? Perfect. And then after francium should come which one, guys? Calcium, right? Because it's the second furthest apart. And then after calcium should come aluminum, phosphorus, sulfur, chlorine, and then finally fluorine, right? Because that's, yeah, it's the last one, right? So yeah, perfect. Now moving on to the next slide. So for this one, it's asking us which is more electronegative. Okay, so comparing fluorine or oxygen, guys, which is more electronegative? Okay, so our answer for this should be really simple, fluorine. Fluorine is just the most electronegative of them all, so this should be no doubt. But oxygen is also pretty electronegative, right? Since it's next to it. Okay, so now, calcium or aluminum? Aluminum, right? Because aluminum is the one that is closest to the fluorine. And finally, iodine or bromine? For this one, guys, your answer should be iodine. I'm sorry, no. Your answer should be bromine. Because, I forgot to circle it. Bromine or iodide. Bromine is closer to fluorine than iodide. So yeah. And that's on electronegativity, guys. I hope that you find this video helpful. And if you have any questions, feel free to contact any of your peer leaders and go to office hours. And have a great day, guys.